electric field lines, one definition. What is the electric field lines? Definition is asked. Define electric field lines. This is the definition. Electric field lines are the pictorially mapping of, pictorial means by picture, pictorially mapping is a representation of the field by picture. Mapping of the electric field of a configuration of charges. It may be configuration of charges may contain only a single charge or multiple charges. Of the electric field of a configuration of charges. Configuration is combination of charges. Configuration of charges. It is a space curve actually. It is a curve drawn in the space. The curve may be on straight line also. Okay. It is a space curve. It is a space curve drawn in such a way that the electric field, the resultant field, the configuration of charges produces what? A resultant field. The resultant field is in the direction of the tangent to this curve, such a way that the resultant field at any point, is in the direction of tangent drawn to the field lines. Tangent drawn to the field lines. Field lines with space curves. Field lines at that point. I will show some electric field line. I will show electric field lines for some configuration of charges. Okay, this is the definition of what? What are the electric field lines? Define electric field lines. This is the definition. Okay. For a single positive charge, plus Q, the electric field lines are as below. The electric field lines are as below. Okay. It is the plus Q charge plus Q. The electric field lines are radially outwards like this. In this case, the field lines originates at Q and terminates at infinity. Where it ends up at infinity actually. Not only it terminates here, it terminates at infinity. Okay. But I can't draw the line up to infinity. Start from the charge plus Q, electric field lines start from the plus Q and terminates at infinity. Okay. For a negative charge, for a single negative charge minus Q, for a single negative charge, minus Q, the electric field lines are as below. The electric field lines are as shown below, or as shown below. write down the notes simultaneously by, if it is not visible on the screen, on your mobile screen, it is visible on your TV screen as well as it is visible on your computer screen if it is uploaded, but it is not visible on actually on the, I think if you are having a small mobile screen, that is not visible on the mobile screen. Just follow my voice and write down the notes. So it is like this, minus q, the charge is minus q, the field lines are radially inverse. The field lines are now radially inverse. In this case, the field lines originates at infinity. This line extends to infinity and terminates at minus q. Okay, originates at infinity and terminates at minus q. Okay, originates at infinity and terminates at minus q. For a pair of charges with opposite polarity plus q and minus q, the field lines are as below. For a pair of charges minus q and plus q, the field lines are as below. The field lines are as below. Here it is plus q, the charge is plus q, and here is the charge minus q. Okay, point charges. For a pair of point charges plus q, and here it originates from, this case originates from plus infinity, sorry, plus q, and terminates at minus q, like this. Just like magnetic field lines. I think we have studied magnetic field lines. Originate at N, terminate at S. No? A magnet with south and north pole originates at N and terminates at S, like that. These are the field lines. Originates at plus Q and terminates at minus Q. Like that. It is minus Q. The charge here is minus Q. Like that. Okay. Here a tangent at this point. What is the direction of the field at this point? This is the direction of the tangent. This is the tangent. No, this is the direction of the bar. So an arrow mark should be done for the field lines. Okay. That gives the direction of the field lines. Arrow mark gives the direction of the field lines. And a tangent is drawn. Okay. This is the tangent. Tangent is a line. Just touches tangent to a curve with a line. Just touches the curve at one point. The resultant field at this point is in the direction of the tangent. This line is the tangent line. Okay. In the direction of the field, in the direction of the curve only. The curve is field lines are in this direction. And the tangent is drawn. Tangent is a line. Line has two directions, but field has unidirection. Field is a vector quantity. It has unidirection. In which direction the field at a point for a configuration of charges lies? It is in the direction of the electric field lines. Electric field lines are also in the direction, in this direction, and electric field is also in that direction. Okay. For a pair of two positive charges, for a pair of two positive charges, why the field lines are originated plus q and minus q? Because of the theory of, so here it is positive charges attracts the negative charges. Because of the theory, it originates at plus q and terminates at minus q. Okay. And for a pair of two they repulse. The field are plus q or minus q repulse. Therefore, in that case, field line converges from one charge to another charge, they diverges. For a pair of two positive charges, q and q plus q and plus q, the electric field lines are as below. Here it is plus q and here also plus q. Plus and plus the repulse, therefore the field lines are also repulsive in nature. Okay. Repulsive in the sense they are not converging, they are diverging like this. Plus q means field lines are outwards. Like for a pair of charges, plus q and plus q. If it is minus q and minus q, minus q and minus q, minus q and minus q, then same figure, but the field lines are radially inwards. Then it is field lines are inwards towards the negative charge. It is not minus q and minus q. Field lines are inwards. Inwards means the arrow mark should be taken. It is minus q and it is minus q. Therefore, a configuration of two charges with minus q and minus q, same figure, but what? The field lines are inwards like this. Okay. Now, some properties of electric field lines. Okay, properties of electric field lines. Properties of electric field lines. Important. Just sometimes you will ask to answer properties. So the figure itself is just the properties. First one, the field lines originate from plus q and terminates at minus q. Okay, field lines originates at plus q and terminates at minus q. For a pair of two charges, plus q and minus q, the originates at plus q, terminates at minus q. And for a single positive charge, for a plus q charge, single positive charge plus q, it originates at the charge and terminates at infinity. For a single negative charge minus q, it originates at infinity and terminates at the charge. Okay. So that is one property. Second property is no two field lines intersects. No two field lines intersect at a point. Two field lines never intersect. If it is intersecting at a point, look here. So at this point, the tangent is drawn to both the curves. Means I don't know the field is in the direction of the tangent. So at this point, the field is in the direction of the tangent. Means it is in this direction as well as in this direction. How it is possible? Field is unidirectional. Therefore, field at a particular point is in the two direction is observed. Because field is unidirectional, it means two field lines never intersect. And the third property is the direction of the field at any point is tangential to the electric field lines at that point in the direction of the field lines. Okay. And fourth property is, number of properties are there. Electric field lines do not form a closed loop. Four properties are enough. Does not form a closed loop. We start from plus q and there will be terminates. Closed loop is not possible. Okay. So it does not originate at a particular charge and terminates at that charge only is not possible. Either charge is plus or minus. Okay. Okay, does not form a closed loop. Those are the properties. First one, field lines start from positive charge and ends at negative charge. Field lines starts from positive charges and ends at negative charges. Okay, this is the starting plus q and terminates at minus q. They may start or end at infinity if there is a single charge. If there is a single positive charge, it starts at the charge and ends at infinity. The field lines ends at infinity. The field lines originates. Okay, originates at the charge and ends at infinity. This is the single positive charge now, starts at charge and terminates at infinity. Means this field lines extends up to infinity. Okay, up to infinity the field lines can be extended. For a single negative charge, field lines originates at infinity. Field lines originates or starts. Originates at infinity and ends at the charge. Ends at the negative, terminates. Ends means terminates. Starts means originates. They will born at infinity and they dies at the negative charge. That is the meaning of originates and terminates. And terminates or starts and ends. If the word originates and ends, terminates are difficult for you, you can use the word starts and ends. And terminates at the charge. Okay. No two field lines intersects. No two field lines intersects. No, second one. No two field lines intersect at a point in the space the field lines are the space curves drawn in the space, even though it is drawn on the board. Actually, the charge is kept in the field, in the space, and in all direction field lines will be there, upwards, downwards, rightwards, in all directions the field lines will be there. They won't intersect. Two field lines won't intersect at a point. Why they won't intersect? Because the electric field is unidirectional. Because in bracket, why they do not intersect? The reasoning for that one is electric field at a point is unidirectional, because electric field at a point is unidirectional, because electric field is a vector quantity. Vector quantity at a point is having single direction. Electric field at a point is in one particular direction. At a point, two direction is not possible for a vector. At a point, two direction for a vector is not possible. is unidirectional. Third one, electric field does not form a closed loop, means starts at a particular charge and ends at that particular charge only, not possible. Electric field field lines does not forms a closed loop. Why they does not form the closed loop? Suppose why they does not form a closed loop, the reason is asked. Then the reason is conservation of nature of electric field, because electric field is conservative in nature, because electric field is because it's not necessary. Properties is asked, only main point is explanation is not necessary, because it's not necessary. But if it is asked why two electric field lines does not intersect, this is explanation for this one. Okay, because electric field is conservative in nature. Electric field is electric force are conservative. Electric field is conservative in nature. Conservative in nature. Last year I studied the conservative forces and non-conservative forces. Conservative force, work done by the conservative force, actually is the path followed by a conservative. The path followed in work done by a conservative force does not form a closed loop. Okay, that's why electric field is conservative in nature. Conservative forces and non-conservative forces. Conservative forces is one where the work done by that force is path independent. Is work done by that force. If force is said to be conservative, if the work done by that force is conservative, it does not form a closed loop, and the force is said to be conservative if the work done by that force can follow any path. The path is path independent, but it depends only on the initial point and the final point of the path. It is path independent, and the work done by conservative force does not form a closed loop. The path does not form a closed loop. Conservative forces are better. The definition of conservative force. First year, conservative force is that force when the work done by the conservative force is path independent, and path does not form a closed loop. Okay, and fourth one is the direction of the field at any point. The direction of the field at any point is tangential to the curve, tangential to the field line, curve at that point in the direction of the field lines, One or two marks question will be asked, 2 marks, 3 marks question will be asked. Therefore, remember 1 or 2 important points. The direction of the field at any point is tangential to the field lines, to the field line curves at that point, field line curve at that point in the direction of the field lines. Okay, so how many field lines can be drawn? Suppose here is the plus q, then so infinite number of field lines can be drawn. One can show the field lines crudely like this, or one can show scatteredly like this. So actually you can draw any number of field lines, not necessarily 10 or 12 for a positive charge plus q or like that. So any number of field lines can be shown. So It is simply a pictorial representation of the field. That's all. Now let us come to the next section, dipole. Let us come to the important section, dipole. Let us define dipole. What is this dipole? Dipole is a pair of charges with equal magnitude and opposite in polarity. Means two charges, pair of charges with equal in magnitude, but both the charges are having the same magnitude. One is 2 nanocoulomb, another one is also 2 nanocoulomb, but one is a positive charge and another one is negative charge, and they are kept in the space with a certain separation between them, with a certain distance between them. The distance between them is taken as 2a. That is the dipole. Okay, dipole is a pair of charges. What is the dipole? Dipole is a pair of charges with equal and opposite, equal in magnitude but opposite in polarity. Okay, and they are separated by a distance in the space. The distance between the pair of charges is 2a. In a dipole, there are two charges. One is plus q and another one is minus q. Both are having the same magnitude q, but one is positive charge and another one is negative charge. The separation between them is 2a. Therefore, that is the definition. A dipole, define dipole, this is the definition. So, a dipole is a system of pair of charges, pair of equal and opposite point charges, equal and opposite point charges plus q and minus q. Okay, separated by a distance 2a, separated by a distance 2a. So here is plus q and here is minus q, and the separation between them is 2a with the dipole. Okay. The line join of the charges is called axis of the dipole. The line join of the dipole is, this is the end of the definition. The line join of charges plus q and minus q and minus q is called axis of the dipole. This is the axis of the dipole. Actually, axis of the dipole, di, axis of the dipole, di, POAD. Actually, there is no real line joining what? Plus q and minus q. So, imaginary line is not actually, these two charges are not joined by a real line, just like a metallic wire, not like that. So, it is simply an imaginary line of the dipole. Axis of the dipole, therefore, axis of the dipole equals to 2a. Axis of the dipole is equals to 2a, means length of the axis of the dipole. Axis of the dipole is 2a, means length of the axis of the dipole is 2a. Let us define one quantity, that is dipole moment. Let us define one physical quantity, that is dipole moment of a dipole. What is the dipole moment of a dipole? So it is denoted by p bar, and p bar is equals to simply 2a into the axis of the dipole into magnitude of any one of the charges plus q or minus q, simply q, into p cap. What is the p cap? It is unit vector directed from minus q to plus q. Okay.